Okay, in today's video, we are looking at acceleration. And I want to start this video with a misconception. Acceleration just means getting faster, right? Well, it could be, but technically it is. The rate of change of velocity. And since velocity is a vector quantity, that could be a change in speed, like getting faster. That way the velocity will have changed because I've changed the magnitude of that quantity. Or it could be changing direction. So you can be accelerating even if you're not getting any quicker. An example of that would be moving around in a circle where you are constantly changing direction. Since your velocity would be changing, you are still accelerating. More on that in a later video. Let's pull an equation directly from that definition. A, my acceleration, is equal to change in velocity, so my final velocity minus my initial velocity, divided by time. Note that v is final velocity in meters per second, and u is initial velocity in meters per second. Time is in seconds. You need to get v and u the right way round. And since u comes before v in the alphabet, that's how you can remember that u is the initial velocity. You're welcome. Now, what are the units of acceleration? Well, okay, it is speed, so meters per second, divided by time, seconds. So meters per second times seconds, or meters per second squared. Neat. Okay, time for an example. Find the acceleration of a goat. Yeah, that's right, a goat. As it goes from 1 meter per second to 5 meters per second in 2 seconds. So let's label my variables. 1 is u, 5 is v, and 2 is t. V minus u over t is equal to a, so 5 minus 1 divided by 2 is equal to 2 meters per second squared. You're not going to believe your luck. There is another equation that you can use for acceleration. Why do we need 2? Well, this one has distance in it instead of time, and it looks like this. Don't panic. Well, yeah, that looks pretty hideous, to be fair. It's actually not too bad. V is still final velocity, but in this equation it's squared. U is still initial velocity, but in this equation it's also squared. A is still your acceleration in meters per second squared, and S is your distance in meters. Well, technically it's your displacement, but it doesn't matter too much for now. Okay, let's do an example. Find the acceleration of a dog that goes from 1 meter per second to 2 meters per second over a distance of 6 meters. So let's label my variables. 1 is my initial speed, u, 2 is my final speed, v, and 6 is my distance, s. V squared minus u squared is equal to 2as. 2 squared minus 1 squared is equal to 2 times a times 6. Okay, so on my left hand side, 2 squared is 4, minus 1 squared, which is 1, gives me 3. On my right hand side, 2 times 6 is 12, so I have 12a. 3 then divided by 12 is equal to 0.25 meters per second squared. Ready for a tricky one? No. A ball is dropped from a height of 1.8 meters. What is its final speed? Air resistance is negligible. So S is equal to 1.8. I don't get it. That's all the information I have. Here's the trick. Sometimes there's hidden information to draw out of the question. Since my ball was dropped, then its initial speed is 0. And since there's no air resistance, so the only force acting on it is its weight, its acceleration is the acceleration due to gravity. This is my quantity, little g. G on Earth is always 10, so I can label that as 10. Okay, so now I have u is 0, s is 1.8, and a is equal to 10. I can find v. v squared minus u squared equals 2as. V squared minus 0 squared equals v squared. And then on my right hand side, I have 2 times 1.8 is 3.6, times 10 is 36. So v squared is equal to 36. Therefore, v is equal to 6 meters per second. Okay, hopefully you found that helpful. Please make sure you like and subscribe. Check out the notes for these equations and the worked examples.